All right, so as we were saying, this line represents a line segment, sorry, a vectored line segment. Now, in vectors, you must have what we call a starting point and an ending point. So, at the starting point of the line, it is labeled as P, capital P. Any letter can be used. So we'll use P to Q right here. So we're saying that we're traveling on a vector from P to Q. So you can use the two capital letters as well. I'm going to show you. Then we have a little common letter here too. There's a common letter on there. Common letter. And most times this common letter, it has a little dash underneath it. Alright? So a little dash underneath it. Alright? So alright. So this is how we represent the vector. Using a directed line segment, and you must label it using the capital letters or use a common letter right here with a dash underneath it. Most times it's oftenly used with the two capital letters. Alright, so some more notes. The length of the line represents the magnitude of the vector. Alright? Of the vector. Length of the line represents the magnitude of the vector. Now my question to you, can we just by looking at the length of the line know the magnitude of the vector? Answer the question, please. Just a second there, please. Alright, let's continue. So the length, yeah, you guys haven't answered my question. Can you, by just looking at the length of looking at the line, determine the magnitude of the vector? Yes or no?
No, sir.
Eh?
No, sir. I think the line should have some form of measurement or something.
Okay. Repeat yourself again, Shelby. Sorry about that.
I'm saying no, sir. I think that the line should have some form of measurement or something.
Okay. So, and suppose a line don't have the measurement, what would it have to do? What would it have to do? Hmm? Hello? Hmm? What would I have to do to find the measurement, people? The obvious question, I don't know, but sometimes the obvious things are not seen by a person, so I just want to make sure so you not see it. Just answer the question. Alright, well, I'm not ready for answer the question. The arrow shows the direction of the vector, as I told you before. Alright? So you have two information there. Now, so now we're going to look at the notation now of the vector. It says we use one or two letters to represent, like seriously, one or two letters to represent a vector. Good? So as I told you before, so now we'll show you the two letter thing though. Two letter represent representation representations. Alright, so you write it to the arrow like that. It is shown like this in some textbooks, or you just have it by itself like this, right? So those are the two letters. You can use it that way. Alright? Everybody see that? Everybody see that?
Yes, sir. Yes, sir.
Oh, I'm told
Yeah.
tell her say if you don't pay attention, he's a man. I like them, there's something there. I just want more space on the board. Instead, I can put this up some more. goes to the two-letter system. So the one letter now is like what I was showing you right here. So let's write that in the notes. And then the one letter now, representation. Representations. Use A, comma A with a dash, or you can use the comma A without the dash. So write with the dash. Yeah. You are the comma A with the dash or without the dash. Alright? So this is how we represent the vectors. Now, the magnitude of or length of the vectors is written as, I'm going to show you how to write it. Alright. So the magnitude or length of the vector TQ is written as this, like that. So please note it has the two brackets, square brackets around it, not the circle but square brackets. So when you talk about the magnitude, you can't just write it like this, you have to write with the straight line between the two straight lines right there. All right. And then final piece of note on this, a unit vector has a magnitude equal to 1. So write that down. A unit vector has a magnitude equal to 1. So when you work out the magnitude of a vector and it equal to 1, it is called a unit vector. All right. So a unit vector has a magnitude equal to 1. All right. All right. Let me know when you guys finish writing off the notes, please, so I can proceed. If you have any questions. No problem. Are you finished? You guys, everybody finished writing off the notes?
Yes, sir.
Alright, so we're going to continue from here. Alright, so we just looked at representing the vector. Alright, so that means the vectors has to be represented so that you know how to identify them. Alright. Alright. So we'll look at the position vectors. Okay. Alright, so we'll look at position vector now. Alright. This the two crucial things to look at. All right, so um, position vectors. We're going to go on to that next. Now, it's very important for us to understand position vectors and also what we call displacement vectors. Those are the two key things in vectors. All right. So we're going to pay special attention to that. All right. Before going to that, we're going to draw up a little line. With a graph. Let's put in my graph. Where is my little graph? There's my graph board. So too large. This is, I think this is decent size. All right, so here we have a graph now. Are we going to be drawing a line and we're going to be determining the vector. All right, so let's draw a little line. I want it a little bit thicker. It's a red color. A little bit thicker. Okay, 5. All right, so here we're going to draw a little line. So that's our line segment. Now we want to determine the vector of this line. So we're going to try, first of all, we're going to identify vectors of the lines first, and then we can start with the position vector itself, right? Is that okay?
Yes, sir.
All right.
Yes, sir.
All right. Good. Now to find the vector of that line, you again we're gonna start from the starting point of it. Let's give this a letter. Let's call it letter O. Call it letter A. All right. All right. So let's determine the vector now. Watch me carefully. Remember, so we have to have a little line too, right? All right. So watch the vector now. So from here to here is 1, 2, 3. Then 1, 2, 3. So the vector of this line is written as like this. I'm sure it is written now. So it's OA, and that is equal to 3, 3. All right? That is what it is equal to. Now, so we started from O. We counted three spaces in this direction along the horizontal axis. And in mathematics, we refer to it as the x-axis. And then we counted 3 spaces up on the vertical axis, and we call it the y-axis. So these numbers here represent the number of spaces counted. Is that clear? Is that clear?
Yes, sir. Yes, sir.
Sir.
Okay. 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 All right. Now, let's give you a chance now to draw one for yourself, to determine one for yourself. Let's call that OB. Can somebody tell me what the vector OB is?
Sir, OB is 3/4.
You sure? Count the vector. You see, you never look what I do a while ago. I'm gonna tell you which number must come first, didn't I? Hmm?
OB 4/3.
4/3. Okay, Sheva gave the answer to 4/3. So let's look at it now. Tell me how I must write it. Tell me how I should write it.
OB.
So remember the arrow you must have the arrow thing too.
Yeah, OB with the arrow over it.
Mm-hmm. And that is equal to
4.
4 over 3.
Yeah, bracket.
All right, the bracket is there. All right. So you know how to identify vectors, but there's another way around now. All right, let's try another vector now to see what you're gonna tell me this time. What's the vector for that one now? Hmm? Alright, so I see somebody said 3/3.
OC.
O
No, CO.
CO.
Yeah. C.
You observe. Hold on there. Alright, so you get one part to correct the for. Hold on there, please. So it's a CO. Okay.
Yeah. I can't remember the direction turns
And back to
pointing down.
very good observation. So what's the other number them gonna?
Four over three.
4/3.
Mm-hmm.
4/3 you get? Now let's check it. So from here to here is 1, 2, 3.
Three. Oh, me start going where the C is.
Yeah, but I'm not down if we go across. If we count horizontal first, please
I
make note
count
of
where
that.
the C is.
Yeah,
One,
but no,
two,
no,
three,
no.
four.
You start from here, so here, so here says 1, then 2, then 3.
All right.
Coming down now, 1,
One,
2, then 3.
3/3.
But what is special about it is a -3 over a -3/7
Why is that?
because of the direction.
Oh. Three pointing down.
Yes.
So
So
when you point it up is a positive.
yes, good. So when you go in this direction, it's negative. When you're coming down, it's negative. You're going in this direction, it's positive. When you're going up, it's positive. All right. Okay. Please make note of that. Mhm. So everybody get that?
Yes.
All right. Let's draw another vector now to see what I'm gonna tell me this time. Mhm. What's this vector now?
OD. OD.
Yeah. All right. Hold on there. So we have OD, that is equal to now
4.
just 4, just so? Just 4, so? Two numbers you must have now, that's 1. What's the second number? What do you think the second number is?
4.
The first number is 4. So from here it says 1, 2, 3, 4. So what's the second number? I want to help her out, Chevel. What's the second number, please?
So you get the second number now.
Sir, 1.
No, or you get 1.
After you go across, sir, then
As they go across, so. You go anywhere else after you go across? Yeah? You go anywhere else after you go across? Hmm? Go make a guess. Come forward. Make a guess, please.
Sir, 4 over 4.
Stop the life on or something. Stop the life on the thing. Come, make a guess quickly.
Sir, I'm only get 4 minutes. Going across, I see.
Then if you're going across, you get 4. So what else now? What do you think it's supposed to be? If the numbers represents the distance counted from a point from one end to the next, then what number would represent? You would use that to represent the next counting.
0.
Exactly. Because when I count now, 0.
Right, 0.
There must be 0, sister. When I apply the meaning of the thing, man, I tell her to apply the meaning.
I mean, I say it couldn't be 1 because it said 1 letter representing something and it couldn't be 1.
Okay, good. So when I understand of a user graph, determine the vector. Alright, so when we re-log in again, we'll start to look more on the position vectors in details. Alright? I'm gonna re-log in again.